the graph of the polar equation R equal cosine theta. It means I need to sketch all the points. So basically what we want is sketch all the point R theta. So all the point whose polar coordinate, point whose polar coordinate R theta that satisfy the condition R equal cosine theta. That's really what we're going to do. Right. So the way we will do it is instead of taking points and points and points, we are going to do two graphs. So let us see what type of two graphs we're going to do. Well, first, the regular Cartesian plane. It means here I'm going to sketch, this is going to be the theta, and this is R. So that's the regular rectangular plane. And here is the actual graph of R equal cosine. So on this graph, everything is in polar coordinate. I'm going to think of this line. This is the line where theta equal to 0. So we call this usually the polar plane. It means a plane where everything we think about is polar coordinate. And this is, I'm going to think about it as the line theta equal pi over 2. Okay. Now, the way we're going to graph is, here I will just ask myself, how is R changing with theta? Just study how is it changing. And then I translate this info from here to here. All right. R is cosine theta, which is actually R equal cosine theta. So how is the graph of cosine? The graph of cosine, it starts at -1. It goes down, up, back up. And after that, the values of R are going to start repeating themselves. And this is -1. Those are value important for us. The value that usually play role when you sketch the graph of R as a function of theta, the value that play role are usually the value where R equal to 0. They play an important role. And like when we have values or max values, those are always important. Now, for the graph of cosine, we know that this is the pi over 2. We know that this is pi. We know that this is 3 pi over 2. And finally, this is 2 pi. Okay. Now, I want to translate everything verbatim. Let's see how we're going to translate it.
What is the height of the graph?
Cosine, remember, cosine. What's maximum value cosine takes? 1.
Oh, okay.
Okay, and the minimum value cosine take is -1. All right, so cosine theta hover between -1 and 1. Now, right. Translate, and you guys will have to help me out a little bit so you can get it. If theta is 0, the theta is 0, R is 1. So it means graphically, when theta is 0, theta equal to R on this line, R, how far we are from the origin, it's 1. So this is the point 1, 0. This is the R, I keep emphasizing, and this is the value of theta, because everything here is in polar coordinate. Now, if theta is pi over...
question on that real quick?
Of course, as go ahead.
Why did you get 1, 0? Why not 1 on pi over 2?
I'm starting here, this point.
Okay.
Theta is what here?
Theta 0 there.
Right. And R?
Wouldn't R be pi over 2 if you're going in the 0 direction?
No. R is 1. If I plug in 0 for theta.
Oh, okay.
It's crucial to understand this.
Okay.
Crucial.
Yeah.
Okay, so on this graph, the vertical distance is the R. The horizontal is theta.
Okay. All right. Thank you. I see. Yep.
Sure, crucial. All right. Now, if theta is pi over 2, what is R? Please answer, because that's how we're going to get through that. If theta is pi over 2, whether you plug it here or you look at your graph, the cosine of pi over 2 is 0. So when theta is pi over 2, my point is here. Now what's happening between 0 and pi over 2? It means, so I'm going to call this region, let us say 1. It means if theta starts sweeping this quarter, theta moves from 0 to pi over 2. What is R doing? If theta goes from 0 to pi over 2, R is decreasing, decreasing, decreasing all the way to 0. So if I'm going to translate this here as theta sweeps this region, R was 1, then it's lost value, then it lost value, sorry, this is nonsense here. Then it keeps losing value, it keeps losing value, finally it's at 0. So this is what theta is doing for us. So as theta sweeps this region, it means as theta go from 0 to pi over 2, as we are in here, the R, it is at 1, then it's getting less, 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 and less. And then it's right there. Question before we move on. So if I had plugged in values, if I had made table, I can do that. I will not get something as accurate as here, because in the table I cannot plug in every value. I would have plugged in only pi over 4 and say, okay, it's going to go like this. But now I know exactly that's what's going, because I know that R is actually decreasing. So that's what reflect 1. The one here, this region, is actually, that's the picture of it. Now we're going to move. Theta, I'm going to let theta stop between pi over 2 and pi. So I'm going to let theta sweeps this region. What is really happening here? At pi over 2, R is 0. At pi, means I plug in pi in here, my R is taking the value -1. So when theta is pi, R is -1. It means the point is right here. So this point is 1, 0, is actually also -1 pi, because those are two representations for the same point. What is happening between that? So I'm going to now emphasize this region. What is R doing? And what is the graph going to be when theta is between pi over 2 and pi? What are the points? In which quadrant are the points going to be?
The fourth quadrant, because R is
They have
negative.
to be in the fourth quadrant, in the quadrant opposite, because the R's are negative. So at pi over 2, I am right here. As we start, as theta starts sweeping this region, my R is negative. Negative, and it's getting more and more negative. So every time theta is here, my R is here. And my R is 0, and then my R starts getting more negative, more negative, more negative. So these are my R's. So they are 0, and they are very symmetric to the previous picture. I mean, those values here are the same. So it's going to go like that. This is, so as when theta is here, my point is here. So we're going to, if we collect, we're going to go around like this. So that's the picture. That's 1. And that's the region 2 is reflected right here. Okay. Now, between pi and 3 pi over 2, what's going to happen? At pi, I'm right here. At 3 pi over 2, it means that theta sweeps this region from here to here. So from pi all the way to 3 pi over 2, it means when theta is here, this region, what is R? R is negative. It means the points that correspond for theta between pi and 3 pi over 2 are going to be back in the first quadrant. Because from between pi and 3 pi over 2, my R is negative. It means my points are in the opposite quadrant. So at 0, at pi, sorry, I am right here. At 3 pi over 2, I am at 0. And in between the r is negative. So instead of the point being here, are going to be will be here. At pi, I am at 1. And after that, they are going to get less and less negative. Now, the symmetry, we're going to force the graph to go over itself a second time. So the graph will go over itself because of the symmetry of the graph. This piece right here and this here, basically, the values of r are going to repeat themselves. So this is going to be 1 and 3. Now, between 3 pi over 2 and 2 pi, r is positive. So when theta is in this quadrant, the r is positive. It means the points are in the same quadrant. They are not changing. And then we are at 0. And then my r will increase. And again, the symmetry will make me go around the circle twice. And that would be the graph. Actually, we can show that this is an actual circle. We can show that this is a circle which is centered right there. We can actually show that. Okay. I'm going to take now another example. So I will take r equal close to what I did yesterday, but I put sine instead of cosine. I think I did cosine yesterday. 1 minus 2 sine theta. All right, and we're going to graph it based on the same principle we're developing. Now, as probably some of you know, and in case you don't, but you should know that your calculator basically graph those, and there are a lot of decimals graph them. So if you're using your calculator, I don't know if you guys use it anymore, you just go to mode, and first you turn it on, you go to mode and you put your calculator in, you go to function and then you move it to, if you want to graph in parametric, you move to parametric. If you want to graph in polar, you move it to polar. And then it does all the graphs for you. So you enter it and then you do the same thing. You put r equal, let's say 1 minus 2 sine theta, and then it will graph it for you. But I don't want to do that. I mean, you guys can check everything you do on your calculator. It will just, you hit that and it will graph it. Then you have to fix a little bit the window because my window is really bad here. Okay, so you can use your calculator to do that, but let us do it without any calculator, right? So the idea here is, again, I'm going to have two graphs. The first is how is theta changing with r? So that's theta. These are the theta values, and these are the r values. And here I translate. So this is, I think of this as my polar plane. And I want to translate verbatim. Okay, so for me, this is theta equals 0. And for me, this is theta equal pi over 2. All right. The first step is to graph this. So let us remember what I did, what I told you yesterday. How is the graph of r equal 1 minus 2 sine theta? First, you start with the graph of sine. You stretch it by a factor of 2. You flip it, then you add 1. Okay, so let us see how the graph of sine looks like. So here I will do the graph of sine. I'm right here. Sine start at the origin, go up, down like this, and then start repeating itself. So the 2 sine will actually go up 2. That's the 2 sine. Okay. Now minus is going to flip it. So minus, we're going to take the graph of minus 2 sine, and then it's going to flip it like that. So that's the minus 2 sine. And then the 1 is going to shift this whole thing by 1. Everything is going to be shifted by 1. So this, my main axis, is going to be shifted up here. So let us do the last one. So first I'm going to draw the 1. That's after we shift. Okay. And then the minus 2. The graph of sine start here. We're going to go 2 units down. We're going to go up. Then we go 2 units up. And then we stop. That's going to be the graph. All right. So let us check some of the points. This is the 2 pi. if this is the midline, this has to be the halfway through. This is the pi. This is right here is the 3 pi over 2. And this is right here is the pi over 2. So these are the values we get by stretching, factor of 2, flipping, and then going up by 1. Now, as I said before, the point that we have to be careful with, and we should immediately figure them out before we do anything, are the value of theta when the r is 0, because those tell me that I am at the origin. Because r equal to 0, I am at the origin. So when we immediately figure out those values. So one is for which theta is r is 0. So we go back and we set 1 minus 2 sine theta equal to 0. It means I'm setting my r equal to 0, and I'm figuring out those. It means the sine of theta, so I'm working with easy angle here, equal a half, right? It means theta equal pi over 6, means this value here is the pi over 6. Now the symmetry of the graph would tell me that this here should be pi minus pi over 6. So the other value would be pi minus pi over 6, which is the 5 pi over 6. So this value here is the 5 pi over 6. Okay, and those are important because r is 0 here. Before it, r is positive. After it, r is negative. And we know something will happen between switching from positive r to a negative r. The whole picture is going to change. Okay, now once we do that, we start. Usually my advice to you is that draw the line where r is 0. What do I mean by that? R is 0 when theta equal pi over 6. It's very helpful for us to draw those lines. Okay, so I draw them here. This is where theta equal pi over 6. They are very good lines to draw. Okay, so so this is pi over 6. Okay, another one line should draw is 5 pi over 6 for the simple reasons that r is also a 0. So I'm going to draw 5 pi over 6. And they will guide us, as you will see in a minute. Okay, so I drew the line theta equal pi over 6, meaning that this angle here is pi over 6. That's really what it means. And I drew 5 pi. It means this angle from here to here is 5 pi over 6. Now we're going to start analyzing step by step. And at this stage, you should help me what to do. All right. If theta equal to 0, what is r? When theta is 0, what is r?
1.
1. Whether I plug it here or I look at my graph, I should have 1. If theta is 0, sine 0 is 0, that's 1. So regardless what we're doing, so the graph is actually reflecting this. So we are at 1 right here. So this is for theta equal to 0. Then what is at pi over 6? Immediately, r is 0. But what's happening between 0 and pi over 6? It means when theta takes a value between 0 and pi over 6, what is r doing? Quickly now. Increasing, decreasing. That's really what I want. Positive, negative. These are the answers I want.
Is it 0?
Yeah, but what is doing? It means when I start taking values of theta,
Decreasing then?
it's decreasing. So theta is r is here, and then it is decreasing up to pi over 6. That's pi over 6. So that's the graph up to here. It means if I take any point here, okay, this is whatever theta is, the r here, that's the one minus 2 sine theta. So if theta is a number less than pi over 6, suppose theta is pi over 12, which is less than pi over 6, it means from here to here, I have 1 minus 2 times sine of 12. So this r here, in this scenario, this is the 1 minus 2 sine. This is the r, which is this is distance from 0 to the origin. In this graph, the r is this vertical distance. So the r means very, very different in different graph. Now what's happening between pi over 6 and pi over 2? Back to you. Means when I take a value of pi from here, between pi over 6 and pi over 2, What's going on?
It's decreasing more.
Yeah, but I want more than that. How is R? Positive or negative? Between pi over 6 and pi over 2. What are the values that R are taking? It means if I plug in a value of theta between pi over 6 and pi over 2, the R will be what? Positive or negative?
Negative.
Negative. You guys are very reluctant. That's your graph. It means if you take R from here to here, the value of R is going to be negative. So try pi over 4, let us say. Pi over 4 is between pi over 6 and pi over 2. If I plug in pi over 4, I will have 1 minus 2 times the square root of 2 over 2. It means 1 which is a negative number. If I take any value from here to here, R is negative. It means when theta is between pi over 6 and pi over 2, if theta is here, in this quadrant or in this piece, the R is negative. It means my R has to be right there because it's negative. So if I take any theta here, the R is going to be right there. It's going to be totally negative. So at pi over 6, I am at 0. At pi over 2, I am right here, which is a minus 1. I am right there. So this is minus 1 pi over 2. So I am at 0 at pi over 6. I am at minus 1. And in between, the R is negative. It means my graph will have to be right there. If I take any value here, since R is negative, it means the point is going to be down in this quadrant. That's going to be the picture. Now we keep going. Between pi over 2 and 5 pi over 6. That's pi over 2, 5 pi over 6. So a theta goes from here all the way to here. So it takes those values. Again, my R is negative. It means my graph is not going to be here. My graph is going to be totally opposite, right there. And let us analyze it. At pi over 2, I am here. At 5 pi over 6, this is 5 pi over 6, I am at 0. If I take any theta in between, my R is going to be negative. My R is going to be negative. So my graph is going to be down here. So we're going to start this way, basically, if I want to put arrow, and then I am right there. Now, I keep moving piece by piece. Now, between 5 pi over 6 and pi, between 5 pi over 6 and pi, this is the easy part. At 5 pi over 6, I am at 0. At pi, I am at 1. And R is positive. It means the picture is in this quadrant and R is increasing. So this is going to give me that, right this. Now after that, and all the picture will be symmetric because of the symmetry in the graph of sine and cosine. After that, between pi and 3 pi over 2. At 3 pi over 2, we're going to be at 3 because we're shifting, the sine was stretched by 2 units, means from here to here we have a 2. So at 3 pi over 2, I am at 3. 3 was going to put me right here at 3 pi over 2. And R is increasing. R is increasing. There are no issues that R is increasing. Now between 3 pi over 2 and 2 pi, 3 pi over 2, R, we are right here, positive, and it's decreasing. So we're starting from here, it decreases all the way to 0. And that will be the graph we get. So plotting point will not actually make us understand the graph the way we can do it now. Here, because we know exactly how is R changing with theta, and I'm translating this all the way to that. Please ask questions as we move on. And I was planning to do one more. I will start it, and then I will like you to finish it yourself. So the last graph I wanted to do with you was r equals sine 2 theta. Okay. Right. But okay, the last 4 minutes, I would like to mention how is the graph of sine 2 theta looks like. Anybody has any idea? If I want to graph it here, so this is the r and this is theta. How does the graph of sine 2 theta? Okay, probably you guys forgot this. I'm sure you did. In general, if y is equal, let us see, sine of b is certain x. So it's like the sine, but bx. How's the graph of this one look like? This look like the graph of sine is the period that changes, because when we multiply x by a constant, we affect the inside. So this one is going to be periodic, like the graph of sine, but the period here is the 2 pi over b. Okay, so I'm sure that you've seen this in your trigonometry class, and I'm sure you forgot it. It means that the graph of this is the same as the graph of the sine, but the period is 2 pi over b. Now, why is this helpful? Because if I want to graph sine 2 theta, how shall I graph it? It's exactly look like the graph of sine, but the period is, so this one, the period is 2 pi over 2. Which is pi. It means it's going to start repeating itself every pi. So it's like the graph of sine, you kind of push it a little bit. So the whole graph happened between 0 and pi. So when I'm going to graph this piece, we're going to get the following. This is the graph of sine, pi, 2 pi. And the graph will be repeat itself. That's a pi, that's the period. And then go back up, down, and that's the 2 pi. So that's really the graph. And I want to sketch it between 0 and 2 pi because I want to go around the whole plane. So this is the theta value, and this is 2 pi. Okay, so the graph of r equals sine 2 theta is going to be exactly this type of a graph. So now I can, if this is pi, this would be the pi over 2. If this is pi, this would be the 3 pi over 2. And those points will be what? What's this point will be? Can you tell me what this point should be?
Pi over 4.
Pi over 4. Okay, and this would be 3 pi over 4. And so on and so forth. All right, so r equals sine 2 theta. It means when you multiply the input by 2, it will affect the period. So if this, the period will be pi, it means you're taking basically the graph of sine and shrink it. So that's the whole graph of sine would be between 0 and pi. And then you start repeating itself. Okay. Now, if I'm going to graph it here, I will spend a minute on that. And I want you to do that at home, and we talk about it on Monday. Between 0 and pi over 2. We know at pi over 4, it's actually maximizing. So at 0, I am right here. At pi over 4, at 0, I am here. At pi over 4, I am here. And this is increasing like that. Between pi over 4 and pi over 2 are decrease and get back here. Now, one question, between pi over 2 and pi. It means when theta is between pi over 2 and pi. Where will the graph be? Where will the graph be?
In the fourth quadrant?
It will be in the fourth quadrant, because right here, my r is negative. My graph is going to be in the fourth quadrant. And it's going to be something like that. Between pi and 3 pi over 2, it's going to be in its own quadrant. Between 3 pi over 2 and 2 pi, it's going to be not in the fourth, in the one opposite to it, because my r is negative. And we're going to have this 4 leaves gloves. Okay. All right. So for Monday, I assigned a few problems from the book. My advice to you is the following. on a sheet of, you have MATLAB, and the MATLAB is going to be easy because you guys can use a calculator. So it's you can do that. I'm not seeing you, but you're not going to learn it. So I strongly advise you to do it this way by yourself and then check. So you know exactly what you're doing, because when I'm going to test you, I'm going to work with that. So I'm going to make sure you can translate info from here to here. So please, I urge you to, when you graph them, I'm giving you easy graphs, on a sheet of paper, graph it like this, then translate and make sure you're doing it the correct way. Okay? All right. Good luck on your quiz.